Hello everyone. In this video, I'm going to explain orthogonal trajectories, and then we're going to do some examples to find the orthogonal trajectories. Let's say you have an equation y is equal to mx plus 0, so you have a bunch of lines going through the origin, and m can be any number, so it can be a positive slope or a negative slope. Then there exists a circle such that when the lines intersect with the circle, it forms a right angle. It doesn't matter the size of the circles or the radius, we can make it big or make it small, and the right angles will still be there. So we call all of the lines family A, or family of curves A, and we call all the circles family B. So it is known that family A and family B are orthogonal trajectories of each other. Let's go ahead and do a simple example. Find the orthogonal trajectories of the family of curves x is equal to k times y to the power of 2, where k is just a constant. The first thing I'm going to do is to try to visualize what the curves look like. So what does x is equal to k times y squared going to look like? Well, if you look at another function, y is equal to x squared, we know that it's just a quadratic function. And if we put a k in front of it, then basically it means we can stretch the curve, or it can also be negative, so it will go down like that. So x is equal to k times y squared. It's just the inverse of this function, so the graph will look something like this. The first step is to differentiate the equation of the family of curves A. So basically we just want to differentiate this equation with respect to x, and let me show you how to do that. We have d over dx of x is equal to d over dx k times y squared. So on the left side, we just have 1, and on the right side, we have k times what is the derivative of y to the power of 2? Well, it's going to be 2 times y, and then because of the chain rule, we also multiply by dy over dx. So basically, whenever you have a y, just multiply it by dy over dx. And what we want to do is separate the dy over dx and just put it on one side of the equation. So the way to do it is to divide both sides by 2yk. So we have dy over dx is equal to 1 over 2 times y times k. And the last thing we want to do is get rid of the k. And that's very easy to do. So if you look at this equation, x is equal to k times y squared, then k will be equal to x over y squared. So plugging this into this equation, we have dy over dx is equal to 1 over 2 times y times k, which is x over y squared. Then we get 1 over 2 times x over y. So this would be equal to y over 2x. Here we have dy over dx is equal to y over 2x, and this is the slope of family A. Now, the second step is to obtain the family of curves B's dy over dx. And so basically we want to find the family of curves that when intersecting with family A, it forms a right angle. So the way to do it, if you remember from high school, let's say you have a line like this, it passes through the origin, and let's say the slope of this guy right here is 1 over 2. Then what is the line that will allow us to form a right angle like that? Well, the slope of the red line must be the negative reciprocal. So the negative reciprocal of 1 over 2 is negative 2 over 1. And that's what we're going to do here with this slope. So we just take the negative reciprocal of this, and the slope dy over dx for the family of curves B will be negative 2x over y. We have the dy over dx for family B, and the third step, or the last step, is to find the actual equation for family B. So from this equation, what we want to do is move all the x and the y's to each side. Now we have y times dy is equal to negative 2x times dx. So what I just did here is multiply both sides by dx and then multiply both sides by y. And so we have this, and we're going to integrate both sides, and we have 1 over 2 times y squared is equal to negative 2 times 1 over 2 x to the power of 2 plus c. So we have 1 over 2 times y squared is equal to negative x squared plus c. So we have x squared plus 1 over 2 times y squared is equal to c. And here is the equation for family B. So what exactly does it look like? Well, if you remember, x squared plus y squared is equal to r squared is the equation of a circle. And in reality, if you graph it, it will look something like this. And there will be right angles like that. So finding the orthogonal trajectories pops up a lot in calculus and also in physics if you're going to take those classes. So let's do another example. Find the orthogonal trajectories of the family of curves x squared plus 2 times y squared is equal to k squared. Now go ahead and pause this video and give it a try, and then we'll go through the solution together. Alright, are you ready? So the first step is to differentiate this equation in terms of x. So d over dx of x squared plus d over dx of 2 times y squared, and that's equal to d over dx of k squared. The derivative of this is 2 times x. The derivative of this is 2 times y times dy over dx. And k is a constant, so the derivative of a constant is 0. And that's quite convenient because we just got rid of the k. This will give us 2x plus 4 times y times dy over dx is equal to 0. And now let's solve for dy over dx. We're going to subtract both sides by 2x, so we get 4y dy over dx is equal to negative 2x, and divide both sides by 4y, so we get dy over dx is equal to negative 2x over 4 times y, and we simplify it, so we get dy over dx is equal to negative x over 2y. So dy over dx is equal to negative x over 2y is the slope equation for the family A. So what is dy over dx for family B? Well, that's the second step. So we take the negative reciprocal. So we get dy over dx is equal to positive 2y over x. And the last step is to find the actual equation for family B. So what we'll do here is move all the x's and all the y's to one side. So let's go ahead and multiply both sides by dx. We get dy is equal to 2y over x times dx. And then divide both sides by 2y. So we get 1 over 2y dy is equal to 1 over x dx. And then we just need to integrate both sides. The integral of 1 over 2y times dy, that's going to be 1 over 2 times the ln of the absolute value of y, and on the right side it is just the ln of x plus c. Now we multiply both sides by 2 to get rid of this. So we get the ln of the absolute value of y is equal to 2 times ln x plus 2c. But instead of writing 2c, it's just a constant anyway, so we can just write it as c. To get rid of the absolute value at x, if you remember, there is a formula. Let's say if you have b times ln of a, that's equal to the ln of a to the power of b. So let's move the 2 up here. And notice that if we have x squared, we don't need the absolute value anymore because x squared is always going to be positive. So let's get rid of the absolute value. Let me show you a way to get rid of ln of y. So you just take e to the power of ln y, and you do the same thing for the right side. So e to the power of ln x squared plus c. So here we have the absolute value of y, and that is equal to e to the power of ln x squared. And we can separate this, so times e to the power of c. So e to the power of ln x squared is just x squared. So x squared times e to the power of c, and here we have the absolute value of y. Now, how to get rid of the absolute value? But if you remember, if we have, let's say the absolute value of x is equal to 3, then x will be plus and minus 3. And we'll do the same thing here. So y is equal to plus and minus e to the power of c times x squared. So let c be equal to plus and minus e to the power of c. Then we have y is equal to c times x squared. And this is the solution to this problem, and that's the equation of family B. So what do they look like? Well, for family A, this looks like the equation of the circle. So we have the equation of the circle. And then the family B is just quadratic, right? So we have something like this. And notice that when it intersects a circle, it will form a right angle. Now it's your turn. So why don't you go ahead and try to find the orthogonal trajectory of the family of curves y is equal to k over x, and the answer to that is x squared minus y squared is equal to c. So that's basically it for today. If you have any questions, please let me know down in the comments below. And if you haven't subscribed already, please subscribe and also share with your classmates. In the next video, I will show you how to solve mixing problems using differential equations.